All right.
You lit. You lit.
All right, let's get our
A
notes
very large
out.
target.
And we're ready for page 8.
So like the girl.
Get your notes out. Now, we're not using these papers I just gave you quite yet. Those are for as we move through the chapter. What we're doing now is back in our notes. We're on page 8 of our
No,
notes.
this is still in this.
And we are going to just solve a few equations. This is a good warm-up for us before we hit some new stuff. Because you should be able to do all these equations right now. So let's look at this first one. Everybody got your notes out? Your packet of notes. We're on page 8. And we are going to solve this equation. What thought do you have? So warm up. Everybody knows how to do this. Well, certainly it's a quadratic equation, so we could think about factoring it. Does that bother anybody?
Oh, yeah.
Yeah, I'm not real excited about doing anything, factoring or otherwise, with a 1/3 in there. So what might I do to fix that? David?
Did you multiply everything by -3?
I think I'll just multiply by +3. Certainly you can multiply by -3. But I want that to be positive. So I'm going to multiply everything by 3. So 3, 3, 3, 3. Now, Liam, yeah, I know the pictures are interesting, but you need to, now, if he wants to factor it, he can try to factor it. Those numbers don't look very promising to me, so what might we do instead of factoring? The quadratic formula. So x equals, which by the way, you need to learn it. So some of you blew some test questions because you don't have the formula memorized yet, and you're going to continue to miss those. Get it memorized. We need that formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 3, b is -12, c is -1. So let's see, that's going to end up being a plus, so it's going to be 144 plus 12. 156. Everybody still with me? Let's review. We've done this before. Let's see, 156 I'm sure breaks down. 2 times 78. And 78 is 2 times 39. And 39 is 3 times 13. Did I do that right?
Yeah.
So what is, how do I break down 156 then? I got a 2, 2, a 3, and a 13. 2 square root 39. Remember, to bring anything out, you have to have 2 of them. So I got 2 2's, but I don't have 2 of anything else. Right? Chair out of the way. Am I done? No, because we can actually cancel out a 2. So our final answer will be 6 plus or minus root 39 over 3.
Yeah.
Are we going to cancel that 3 into that 6? No. Got to have all 3 spots. Yeah, that was easy. That was real. What about this one? What's your thought on this one? Start by foiling? That seems like a very good plan. Foil this out right here. So first, outside, inside last. big equation. Jackson, you got any thoughts on that?
You can factor the left side.
Well, I could try, but because I got stuff on both sides,
Oh wait, actually, pull out an X.
yeah, I probably want to start combining things if I can, right? Now, this guy doesn't have an X, so I'm not going to be able to pull out an X. But could I collect some like terms? Yeah, let's do that. Let's collect some like terms. And then be thinking ahead, what are you going to do then? Let's see, let me make sure I add right here. Is that 4x? Now, think about the one we just did. Before I could solve it, I had to have it set equal to 0. So I might want to think about moving this stuff over here, or this stuff over here, whichever way you want to go. So I'm going to subtract x squared. Now be careful. I'm going to subtract 4x, right? But when I subtract 4x, those don't cancel. That makes negative 8x. Right? Don't get carried away. And then when I add 2, those don't cancel. That makes plus 4. Now, could you divide by 2 if you wanted to? Well, Brownie, what do you think about that now? If it factors, let's factor it. We're going to solve this quadratic equation. And so one option would be to try to factor it. I don't think that one factors, though. So then what? So then we're going to use the quadratic formula. Or this one, actually, for those of you that like to complete the square, you could also complete the square if you wanted. But I like the formula better. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Those are little numbers, so that's not too bad. That's going to be the square root of 8. And you probably know the square root of 8. You've broken that one down so many times. Square root of 8 is 2 root 2. Does that one simplify? So we'll take out the 2, so we're left with 2 plus or minus root 2 over 1, or just 2 plus or minus root 2. Now, look at that. That is a massive problem. But it wasn't hard, right? We just had to take it one step at a time. All right, a couple more. Things are going to get exciting here in a minute. So let's do this quick review. Talked about mathematical modeling yesterday, and these equations are just examples of mathematical models. Tessa, what do you think about this guy? Couldn't hear you. What? Distribute it. Yep. So x squared minus 4x equals 5. Perfect. Yes. What's next? Can we take the square root? The only way we would want to take the square root is if we had something like this. So that when we took the square root, it would just be x plus 1. But if you take the square root of this, you can't take the square root of that. It would just be the square root of that. There would be no way to simplify it. So I don't think that's what we want to do. At least not at this point. Mamuna? You know, I just can't hear. I'm so old and that there's so much noise. What? Move the 5 over. So that's a good plan. She says, let's get it set equal to 0. Guys, isn't that what we've done in our other equations? Haven't we had it set equal to 0? If you are going to use the quadratic formula, you need to have it set equal to 0. If you are going to factor it, you have to have it set equal to 0. So it's a good idea, if you see a squared, to get it set equal to 0. All right, what about that? This one actually does factor. Could we use the quadratic formula if we wanted to? Yeah. Absolutely. But this one does factor. So x equals 5 or x equals -1. Sean, you're looking kind of funny at that. Is that right? Did I make a mistake? Okay. All right, one more. Solomon, you have a plan on this guy? Yeah, let's put stuff together. So you can't really add those two together, but you can move this over there. So we'll add 3x squared. Didn't we just talk about getting it set equal to 0?
Yes.
So we add the 3x squared and then we'll subtract the 10. So minus 15. That look okay? Anybody have an idea? David? B is 0. The B term is 0. You absolutely could use the quadratic formula. A is 4, B is 0, and C is -15. We absolutely can do that. Anytime you have a squared equation, the quadratic formula is an option. Always. So if we did that, we just have -b, that's 0, plus or minus the square root of 0 squared minus 4ac all over 2a. Now that looks a little weird because we don't normally have a b that's 0, but that's what it would be, right?
Yep.
So let's see. That's going to be 0 plus 16 times 15. 240. Does 240 break down? I'm pretty sure it does. So it breaks down into 222, 325. So let's see, I can bring out a 2 and another 2. So that's a 4. Root 15. Is that okay with everybody? And yeah, and how does that simplify? The 4's cancel. There's nothing over here to worry about this time. So I'm allowed to just cancel those. So plus or minus root 15 over 2. Now I want to show you something. I'm going to go back to this equation right here. That what we did is absolutely fine. It will work every single time. Do not feel badly that we did all that. It will work every time. But at this point, because there is no b term, remember a minute ago Tessa wanted to take the square root? What if I added the 15 back over? Now, if I take the square root of both sides, what's the square root of 4x squared? 2x equals plus or minus root 15. And then when I divide by 2, look at what I get as my answer. And that was a little bit faster. But the only reason we could do that is because that b term was gone. But that would be another option for you. Okay, let's take a look now at the next section. Haven't talked about this stuff. You did last year. Take a look at all those little pictures I drew there. Does anybody recognize any of them that are functions? Are any of these things functions? What do you think? Are any of them functions? Jacob?
A, C, E, and then... No, not S.
So A you say is a yes?
Yeah.
What else?
C.
C he says is a yes.
And E.
And E he says is a yes. So these are Jacob's answers then. I presume these are all no's then. What do the rest of you think?
That's right.
How's he doing this? How do you know? How do you make that determination? Lauren? The vertical line test. It's called the vertical line test. So if we look at picture A, and we pass down, and you can either either physically or mentally, pass down a bunch of vertical lines, notice that all those vertical lines hit the curve in only one place, right? As opposed to the second picture, if we passed a vertical line down through here, it would hit in 2 places. So you all remember, hopefully, the vertical line test. It's a test for functions. Are you a function? If you pass the vertical line test, you are a function. So I think his answers are perfect. I think he's exactly right. Everybody remember that? Functions are a set of ordered pairs. So if I look at this picture here, Jacob said this was a function, and he's right. But that thing is just made up of a bunch of points, right? So if I look at all of those points, the x-coordinates comprise the domain. So you've heard of that word before, domain? So in the next question, we're asked for the domain. And the domain is the set of all the x's. It's the x values. We're focusing in on the x values. So when we look at a function, and this is function notation. Can you read this to me? F of x, that's right, f of x. So this is function notation. Your job is to determine the domain. The domain is going to be all real numbers unless 2 things happen, or one or the other, or both things happen. So where domain is concerned, your red flags, the things that make your domain antenna go up, your red flags for domain. The denominator cannot equal 0. Now, when I look at this problem, does it even have a denominator? No. So I don't need to worry about that. I don't need to worry about it. There's no denominator, no problem. The other thing you have to worry about is whatever is under the radical must be positive. I should say greater than or equal to 0. Whatever is under the radical must be greater than or equal to 0. Does that problem have a radical?
No.
No. So here's what I said, and some of you missed it because I just was talking and you weren't listening. The domain is going to be all real numbers unless you have these two red flags. I don't even have a denominator in my problem. I don't even have a radical in my problem. So what's the domain? All real numbers. And the symbol for all real numbers can be written that way if you want to, or you can write all reals. That is the domain. In this problem, there is nothing to be worried about. The things we worry about when we talk about domain, not range, that's a whole different thing, but when we talk about domain, these are the things that we have to worry about. If you don't have a denominator and you don't have a radical, then you don't have a problem. All real numbers. All right, so let's look at the next one, B. Please don't let the G bother you. You can say f of x, g of x, h of x, p of x, q of x. The letter you use doesn't matter. That's just your function notation. So the question is domain. So there are two things I have to look for. Do I have a denominator in this problem? No, so I don't need to worry about that one. Do I have a radical in this problem? Yes. So whatever is under the radical must be greater than or equal to 0. That's the rule. Whatever is under it has to be greater than or equal to 0. So x plus 5 must be greater than or equal to 0, which means my domain is x is greater than or equal to -5. Just solve that. Subtract 5. Solve that. So the domain for problem B is x is greater than or equal to -5. Remember, domain is your x's. So you're telling me that in my set of ordered pairs, if I'm going to graph this, I'm allowed to use any x I want as long as it's bigger than or equal to -5. All right, here's C. The question is domain. What is the domain? And every time someone asks me a domain question, these two things pop into my head. So the first thing I do is ask myself, do I have a denominator? I do. And what do I know about denominators? They cannot be 0. So x plus 5 cannot be 0. Which means x cannot be -5. So what is my domain? Everything except -5. Now, I am perfectly okay with you writing that. In the honors class, in the academic class, they have to write it like this. See if this makes sense to you. That's a lot more writing. But doesn't it say the same thing? This says everything from -infinity to -5, and then everything from -5 to infinity. Isn't that everything except -5? Uh-huh. We say exactly the same thing. I'm perfectly okay with this, but if you want to write it formally, this is the way it would be written. Just like instead of saying all real numbers, we rewrite it like this. That's the formal way of saying all real numbers. -infinity to +infinity. And this one, the formal way would be this. Start at -5 and go all the way to +infinity. But I'm okay, totally okay, with this and this and this. Liam? Just stretching? Alright, I'm going to erase my flags over here. Hopefully you have those written down. They're really, really important. Okay, let's take a look at the next one. Your job is to find the domain. So it's the first thing you ask yourself. Do I have a denominator? I do. And I know that whatever that denominator is, it cannot be 0. Which means that x cannot be 1/4. There's my domain. X can't be 1/4. Everything except 1/4. Which again, you can write with intervals if you want to. But this is everything except 1/4. We're gonna be graphing these shortly, and that has huge graphical implications. That's important. You have to know your domain if you're gonna graph. E is a tricky problem. Alright, so we've done a couple problems now. Domain, we're finding domain. What pops into your head when I say find the domain? Two things need to pop in your head. What are the two things? Denominator cannot be 0, and whatever is under the radical has to be greater than or equal to 0. Now, I don't have a radical, so I'm not going to worry about that one, but I do have a fraction, right? So the denominator cannot be 0, period, ever. The denominator can't be 0. Now, what makes this problem a little tricky is, what happens when you try to solve this? Right? And then I can divide, and then what would I have to do next? Square root. And what's going to happen over here? It's going to be imaginary, isn't it? Isn't it imaginary? We're talking about graphing this on the real number plane. So what's your conclusion?
Yeah, no solution.
It's not, actually, it's just the opposite of that. The domain is all real numbers. The domain, remember, you're looking for the domain. This isn't solvable over the set of real numbers. That's right. But we're looking for the domain. And the domain says whatever's in the denominator can't be 0. This tells me there aren't any numbers that make the denominator 0. If nothing makes the denominator 0, then our domain is everything. Yeah. That's a little tricky. This basically says there aren't any restrictions. X can be anything real. The only thing it can't be is something imaginary, which we don't care about. So your domain is all real numbers. That's tricky. All right, would you try F on your own? See if you can figure out the domain for F. Oh, not in the ring. So think about your two rules. You don't even have a radical, so you don't need to worry about that. You do have a denominator, though. So what do we know about our denominator? Can't be 0. Super. So what does that mean? If you said x cannot be 0, you are exactly right. Because if we're looking for domain, the domain says the denominator can't be 0, which means x can't be 0. All right, did everybody say that? X can't be 0? Oh, you're wonderful human beings. Good job. What about the next one? What do you think about that one? Would it be all real numbers? Is the domain all real numbers? Lauren, you had your hand up and now it's down. What does that mean?
I was gonna say,
Can't hear you. What?
couldn't you just factor it?
Oh, she says, can you factor it? So we definitely could factor it. And actually the top two. The top isn't really of concern to me when I'm talking domain, but I can certainly factor it. Okay, what does that do for me? Okay, what's our rule again? The denominator can't be 0, right? So the denominator can't be 0. Can that ever be 0? Are there any, can you think of a number that would make this 0? -3?
Yeah.
Can you think of a number that would make that 0?
Positive 3.
I don't think our domain's all real numbers. I think our domain is x can't be -3 or +3. Does that make sense to you? I know some of you saw the squared and said, oh, it's just like this problem. No, it's not. This was x squared plus something. This is x squared minus something. That can be 0. If you put in a 3, won't that be 0? Yeah. You can't put in a 3 or a -3. So if we graph this one, there would be 2 breaks in the curve because there's 2 values that x can't be. And we're getting ready to graph here in just a couple minutes. First we have to do h. Uh-oh. Uh-oh, look at h. The question says, what's the domain? Okay, so there's 2 things I think about. The first thing I think about is the denominator cannot be 0. So Emmett says x cannot be 2. Perfect, that's a good starting place. What's the other rule about domain no?
No, the radical.
Whatever is under the radical
is greater than 0.
has to be greater than or equal to 0. So whatever is under the radical is greater than or equal to 0, positive. So that means x has to be greater than or equal to -5.
Yeah.
So your domain is a combination of these 2 things. Your domain is everything greater than or equal to -5 except 2. Everything greater than or equal to -5 except 2. Because anytime you're talking about domain, you need to be concerned about 2 things. Your denominator cannot be 0, and your radicand, the thing underneath the radical sign, must be greater than or equal to 0. So both of these are the answer. You will put both of these down in the answer blank. That's your domain. Everything bigger than or equal to -5 except 2. Alright, couple more. Rock, domain, denominator cannot be 0. Well, we don't even have a denominator. So then I'm going to move on to the next thing, which says what? Whatever's under the radical, which in this case is 2 minus x, has to be greater than or equal to 0. Now be careful on this one. I'm not sure how you want to solve this. Subtract the 2. Now when you subtract the 2, this is what you're going to have left. And then you're going to divide by the negative, but that's going to turn the sign. So your domain this time is actually x is less than or equal to 2. Yep, positive less than or equal to positive 2. Kayla, you want to put your head up for me, sweet pea? Thanks. Someone might walk in and think you're bored, and I totally know that's not the case. All right, one more. What's the domain for this? Well, what are our rules? Denominator can't be 0. I don't have a denominator. Whatever is under the radical has to be greater than or equal to 0. So if I subtract the 1 and divide by the 3, my domain is everything greater than or equal to negative 3. Okay. David?
So when you're not trying on the domain, the only time you use the numerator is when it has the squares on it?
Yeah. Yeah, when you're talking about domain, indeed. Yep, with domain, there are 2 things we worry about, denominator and radical. Okay, so guess what's going to happen tomorrow? You're going to have a little quiz, and it's going to have 2 questions on it. And they'll take a wild guess what the 2 questions are going to be. No range, not yet, no range. We're going to have a domain question, so I'm going to give you a function and say, what's the domain? And when I say that, when I say, what's the domain, 2 things pop into your head. Denominator can't be 0, and whatever's under the radical has to be greater than or equal to 0, right?
Yeah.
And then what's the other question, do you think? How did we start the period? The quadratic, right? I'm going to give you some weird, funky equation like the ones we started class with. And you're going to move things around, come up, find like terms, get it set equal to 0. And then either try to factor it or use the quadratic formula on it, right? For those of you that don't know the quadratic formula yet, this is another problem you're going to miss. So please, please, please come tomorrow with that learned. All right, so that's the quiz. Now, there are some other things we're going to talk about today that are not on the quiz. We are going to begin this graphing process. And we're going to start by not graphing the whole thing, but just putting in the vertical asymptotes. Anybody know what an asymptote is? What do we even mean by asymptote? No one knows? You don't know what asymptotes are? Well, there can be all kinds of asymptotes. In this case, we're going to have vertical asymptotes. But an asymptote is a line that the curve approaches but doesn't intersect. So the easiest ones I can think of, did you guys study hyperbolas last year? Did you graph hyperbolas? No. Yes, some of you did, some of you didn't. Okay. Hyperbolas are shapes like this. So this would be, that's what we call a hyperbola. And these lines right here are the asymptotes. Because the farther out I draw the curve, can you see what's happening? It's going to get closer and closer to that asymptote, but it's never going to touch it. So asymptotes are kind of like the guidelines. The curve follows them on the way out, but never intersects them. Now these are not these are not vertical asymptotes. We're going to graph vertical asymptotes for these curves. These are not hyperbolas. These things are weird shapes. we're gonna learn how to graph them, okay? Vertical asymptotes are tied directly to domain. Remember, denominators cannot equal 0. Vertical asymptotes happen when the denominator equals 0. You have a vertical asymptote every time your denominator equals 0. So, where would the vertical asymptote be for this guy? What would make this 0? Positive 1. So you are going to draw a dashed line and label it 1. X equals 1. That is your vertical asymptote. Right here where x is 1. Right there where x is 1. That's your vertical asymptote. Notice that if I said, what's the domain? You would say x can't be 1 because a vertical asymptote is a line that the curve approaches but doesn't intersect. So it's never going to touch where x is 1 because x can't be 1. Whatever your domain is, that's where your vertical asymptote is going to be. So where's the vertical asymptote in this problem? Okay, what would your domain be? Wouldn't you
Would it
say
be negative
3x minus 5 can't be 0? So 3x can't be 5 and x can't be 5/3? That's your domain? So where is your vertical asymptote? 5/3. And 5/3 is 1 2/3. That's how come I put it between 1 and 2. That's 1 2/3. There's my vertical asymptote. What about the next one? What do you think? Where's the vertical asymptote for that one? Lauren? Exactly, so there's two vertical asymptotes. There's one at 2, and there's one at -2. Kids, how did we come up with that? Yeah, that denominator right there factors. So there's two things that would give me a 0. I could get a 0 with -2, and I could get a 0 with +2. We're going to learn the shapes that go in here, but we're starting with the vertical asymptotes. They give us the framework of the graph. All right, one more easy one, and then it gets a little harder. What about D? Where are the vertical asymptotes for this problem? Okay, so that factors. So if I factor that, let's see, I want to make sure I get it factored correctly. The x minus 5 plus 1. So I'm going to have an asymptote at 1, 2, 3, 4, 5 at x equals 5. Because what happens if I put a 5 in there? Don't I get 0? Yeah, that's how I get asymptotes, vertical asymptotes. What goes in here to give me 0? -1. So you have two asymptotes. One is at 5 and one is at -1. Now the next one is really, really tricky. What do you think? Anybody notice anything about this problem? It factors, and not just the bottom factors, but also the top. So let's see, how would the top factor? X plus 1, x minus 1, perfect. And how about the bottom? It's really the bottom I care about, but let's see what happens here. How does the bottom factor?
-1
So minus 1 and positive 5. Let's double check that and make sure that's right. I think that's right. Do you notice anything? Oh, we have something that cancels. Boys and girls, this introduces something that's going to be important for us when that happens. When you can cancel, it is not an asymptote. It is a hole. A hole is simply an open circle in the graph. Now, at this point, we're not graphing them, but I want you to know there is going to be a hole at the point where x is 1. If you put a 1 in here, you get 0, but that 0 cancels out with this 0. So it's not an asymptote, it's gone from the problem. Where is the vertical asymptote going to be? The vertical asymptote is going to be where x equals -5. Vertical asymptotes happen when the denominator is 0. Well, the denominator is 0 at 1, but that's not an asymptote because it cancels out with 1 in the numerator. It's a hole. You probably noticed that one of the papers I gave you, if you were looking at those, said label all the asymptotes and holes or something. The word holes was on that. This is where they come from. Holes happen when you can cancel. So, in terms of a vertical asymptote, you only have one, and it's right here at -5. That's the only vertical asymptote in that problem. We thought there might be 2, like there were over here, but nope, because one of them canceled. What about F? So we're going to factor everything. All right. How does the top factor?
X plus 5.
+5 plus 4. That seems okay. How does the bottom factor? -4 plus 4. Uh-oh, we're going to have a hole, right? We're going to have a hole. We thought we were going to have 2 asymptotes, but that one canceled. So there's going to be a hole where x is -4. The hole is a point. When I graph it, it's going to look like this. I mean, there's going to be an actual open circle in there. So it's a point where x is -4. Where is my vertical asymptote going to be?
4.
At +4. Because where do vertical asymptotes come from? I erased it, but they come from things that make the denominator 0. That's where you get vertical asymptotes. Oh my goodness, one more. Oh Lord. Oh, probably not going to get this one done. So, let's not start this one. It's going to be a little harder. How am I going to get that bottom factor? I'm going to have to group it. Yeah, I'm going to have to group it. We'll see what cancels out. So we'll start there. That's a good place to start tomorrow. Remember, we have a small little quiz tomorrow. We don't have this class tomorrow?
No.
Well, then we'll have our small little quiz on Friday. I will see you on Friday.
Kick cat.
Yes. So I will see you tomorrow. Or Friday, yeah, you already told me that. Solomon, my friend, we don't chew gum